Good afternoon, everyone. I welcome all of you to the second session of our online faculty development program on AI in cloud computing theory, practice, and application. So, in the first session, we have seen the fundamental aspects of cloud computing. Especially, we have seen what are the different type of cloud as per the deployment model, and we have also seen service model. So if you go for the deployment model perspective, then we can say there is a public cloud, private cloud, community cloud, and hybrid cloud. But when you go for service model side, we call that as a infrastructure as a service, platform as a service, and software as a service. And we have also seen what are the advantages and disadvantages of cloud computing. And we have also seen some of the aspects of virtualization and different type of virtualization. So proceed further, we will discuss in this session about cloud computing architecture. So like if you all of you are belongs to computer science branch, you heard about one of the architecture that is called a John von Neumann architecture. So our modern computer systems are following John von Neumann architecture. So in John von Neumann architecture, if you remember, we have a input unit, we have a processing unit, and we have a output unit. Okay. So we have memory unit also. So this is a simple architecture. So every technology, whether it is a Internet of Things or artificial intelligence, machine learning, whatever may be, we have a particular architecture, right? In some sense. I cannot say that there is only one standardized architecture, but we have different type of architecture based upon the application. We can say which architecture is more suitable. So this session will focus on the cloud computing architecture, and we'll see how it is different from network architecture or John von Neumann architecture. So these are the topics that I am going to discuss in this session. We'll start with introduction. I'll tell you the introduction from the birth of a computer system to the latest inventions or innovations in the field of computing. And we'll see different type of technologies that are, you can say, predecessor of cloud computing and successor of the cloud computing. Then we'll discuss about the cloud marketplace, or we can say global cloud marketplace. So all of us know about the marketplace where we purchase something, or marketplace where we sell something. So similarly, in the case of cloud, we have a marketplace where the buying and selling process is done. Okay, that means there is some buyers and there is some buyers, then there is some providers. Okay, so they meet a particular point which we call as marketplace. Similarly, in the cloud case also, we have a marketplace where we provide the service or where we get the service, right? In two different perspectives. So that view we are going to discuss. Then I'll tell you a very popular architecture proposed by Professor Kumar from University of Melbourne. So there is a architecture, they call that architecture as market-oriented architecture. Okay. So you can see like if you go for Amazon Web Service, AWS, or if you go for Google Cloud, or you go for IBM Cloud, every cloud is having an architecture, right? Similarly, based on the market perspective, so they developed one architecture that is called as market-oriented architecture. In market-oriented architecture, one of the components is called as pricing. So you know that pricing of cloud, if you cloud service, if you are using, so pricing varies with respect to time. So for example, I can say daytime, the price is more in comparison to the night time. Okay, so that is one type of pricing. Or I can say irrespective of the time, I am going to fix a particular price. So based upon that, there are different type of pricing mechanisms we have. So I'll tell you about some of the pricing mechanism, and based upon that, we are going to solve couple of problems. So some of the numerical problems we are going to solve using the pricing mechanism. Next, there is another important concept that is called as granularity. Granularity, you can say whether when we decompose a component into subcomponent, or when you decompose again subcomponent to subcomponents. Okay, so when you generate task, or when you generate subtask or subtask, so there is a concept called granularity. So there may be high granularity, or there may be low granularity, or there may be a fine granularity, or there may be a coarse granularity. So we'll discuss about granularity, how much deeper we are going to make it possible. So that is based upon the granularity. Then we will discuss about some of the other architecture, which we call as high-level architectural approach. Some of the high-level architectural approach is based upon the service model. Some of the architectural approaches are based upon the deployment model. Okay, so we'll see overall what is the high-level architectural approach, and it also introduces different types of services. I can say, like you heard about infrastructure as a service, platform as a service, software as a service. So we have another type of service where we generalize all the types of service, which we call as XaaS, everything or anything as a service. Then we'll discuss about the process of migration. So the process of migration we generally use when you want to move from one place to another place. Like in education system, we call it migration certificate, right? So when we move from one university to another university, where both are having different model, then we need one certificate that is called as migration certificate. So similarly, in the case of cloud, the VMs that are taking resources of a physical machine, so they can move from one physical machine to another physical machine. So that is actually called as the process of migration. Then how we perform this migration, again based upon that we have different type of techniques we have. So whether we need to pause the execution, or we continue the education, continue the execution. So that is based upon the different type of migration. So that we will discuss, followed by the conclusion and references. So coming to the roadmap of computing. So in this slide, you can see I am showing you some of the computing which is in my mind from 1822 to 2016, in which you can find the cloud computing in the year of 2006. So any computing that is developed before 2006 can be considered as the predecessor of the cloud computing. In fact, we have seen also different type of computing that are considered as the backbone of cloud computing. Similarly, not only that, after 2006, there are some successors of the cloud computing also. Like here you can see I have listed 3, but there are many. Okay, you can find they are the successor of the cloud computing, which uses cloud computing as the backbone, you can say, right? So if you see this total this roadmap, you can see earlier, if you see long back, Charles Babbage, who is considered as who is called as the father of the computer. So he developed a very simple machine, which is not the complete system, I can say, in 1822, but the birth of computer started from 1822. But if you see a full-fledged computer which can do computation, although it is very bigger, and so many devices are associated with that computer, that was started in the year of 1930. We call that as a mainframe computer. So in fact, at that time, mainframe computers are only very rare, so that are available only very few places. So when you want to execute a particular job, you have to go there and put your job as a in the batch, right? And put your job in the batch. Then you may get the result after 48 hours or 72 hours or so on, right? Then people have come up with electronic numerical integrator and computer, which we call as ENIAC. Okay, this is considered as the fast electronics computer. And later point of time, ENIAC also developed, ENIAC is improved which we call as electronic discrete variable automatic computer, or that is called as IDVAC. Okay, so day by day, number of you can see the size of the computer system is going to be reduced, cost is also reduced, and competition power is also increased, right? In comparison to that, competition power is day by day it is increasing. Similarly, till 19, you can see before 1950, all the computation which we are doing, they are more or less the single computing resources. Means there is only one processor. We have never thought of the parallel computing. Okay, so 1950 people have started a new type of computing that is called as parallel computing, in which two different works can be done, two or more works can be done simultaneously. Similarly, in 1960, we have a large-scale computer system architecture. 1967, we have cluster computing, in which we consider a group of nodes of similar architecture, similar behavior, similar operating systems. They are grouped together to provide the services. Because if I say that I need, let's say, 1 TB of RAM. So 1 TB of RAM, if you announce the capacity of a computer system, it is not that much economical, right? It is not possible. It is very expensive. So in order to avoid that, what we can do, instead of enhancing the power of a single computer system, so what I'll do, I'll connect more computer systems. Okay, let's say we have 1024 GB, we require GB of RAM. So let's say we have 1024 computer of 1 GB each. So together we have 1024 GB, or we can say 1 TB. So cluster brings that particular concept. So in order to build a very large system, it is not only it is not only required to enhance the power of a computer system, but also we can combine one system with another system, and we can make a group of systems, right? So that group of system can provide the services. But it is possible to gather hundreds of computer, or you can say thousands of computer. But when you go for a larger number, it is not possible to gather the computer systems that are having same behavior, same characteristics, or same operating system. That's why people have come up with another computing that is called as grid computing. Okay, but prior to that, we have a concept of distributed computing. In distributed computing, they are not only residing in a single organization or single location, but they are distributed over the world. Okay, they are not present in a particular place. So when you go for a centralized computing, it may happen that if there is a failure, that we call it a single point of failure, then the whole network is going to be collapsed. But when you go for distributed computing, is the resources are not placed in a single location. So if a particular computer is failed, so it is not going to impact the other computer system. So that's why distributed computing is very much popular from 1970 onwards. Even in fact, you can see all the computings that came after 1970, they are considered as a parallel computing, as well as they are considered as a distributed computing. Similarly, you can see in 1973, we have the first personal computer. Before 1973, we don't have personal computer. So first personal computer came in the year of 1973. His name is Mikhail N. And 1980, we have client server computing. Then 1988, we have internet-based distributed computing. Then 1990, as I said, enhancement of the cluster computing can be done by the help of grid computing, in which we consider different type of systems, and their configuration is different, their architecture is different, their operating system is different. Then 1998, the concept of utility computing came. Everything is considered as a service. For example, we can say electricity can be considered as a service. Our water bill also now it is considered as a service, right? Based upon our usage, we are going to pay the electric bill, or let's say mobile bill, or we can say the water bill, right? So everything treated as a utility. Later point of time in 1999, we have the concept of virtualization. So we have seen the concept of virtualization in the previous lecture, right? Then we have 2.0 technology came, then peer-to-peer computing came. So these computings are considered as the backbone of the cloud computing. And all the innovations, whatever people have done, so they are summarized by the help of cloud computing. For example, you can say utility computing case, right? Cloud is considered as a utility computing. Cloud can contain a similar type of system, so it can be treated as a cluster computing. Cloud can contain different type of system, so it can be treated as a grid computing. So all the advantages, whatever we have seen in previous computing paradigms that are used in the cloud computing. Then after cloud computing, also people have come up with different type of model, like service-oriented computing came. Then Cisco started fog computing to improve the performance of the cloud computing in 2012. And in 2016, one new computing came that is called as osmotic computing, which is the bridge between, you can say, IoT to edge, or you can say edge to fog, or you can say fog to the cloud. So the idea of showing this roadmap is that computing is not a new one. Computing is there from the long way, but the type of applications we need in day-to-day life, so that is changing. So for that, we need some advanced computing paradigms. Otherwise, parallel computing, distributed computing, you can see 1950 means it is around, we can say 70 years back. Okay, so these computing paradigms are already there. Now, coming to the cloud computing, as I am going to tell you about cloud computing architecture. So we should know what is the importance of cloud computing in why we want to go for the different architecture of the cloud computing. Why one architecture is not standardized till now, right? Why different organizations and different applications also represent different type of architecture. So that we are going to see. But before that, I'll show you a hype cycle. So here you can see there is a hype cycle. This hype cycle is for cloud computing, and this hype cycle was released in the year of July 2023 by one of the research and development firm. We call that firm as a Gartner. So Gartner releases this hype cycle twice in a year, probably in the month of July of every year, and another is in the month of January. Okay. So why this hype cycle is important? Because this hype cycle is followed by academia, as well as the hype cycle is also followed by industry. So you can see in hype cycle, the x-axis represent time and y-axis represent the expectations. So over a period of time, what is the expectation of industry industry for a particular technology? Like I will ask you, okay, I will just I want to know you, right? Over a period of time, how much time or how long cloud computing is going to be one of the you can say emerging area in industry. Okay, or you can ask how many years artificial intelligence or machine learning is going to be in hype in the market, right? So that you can find from this particular hype cycle. For example, if you go to one of the popular technology that I am going to highlight here, that is called as AI model as a service. So more or less, we know there are different types of AI models are there, right? And there are different types of machine learning models are there, deep learning models are there. How to provide these models as a service? So that is considered as one of the aspect in Gartner hype cycle. And if you see, it is represented in a circle with a particular color. So the meaning of this one is that this technology is going to sustain in the market for next 2 to 5 years. After 2 to 5 years, every cloud service provider, you can say, they have already implemented this, or this technology is mature. That's why there is no popularity of AI model as a service. Similarly, you can see there is another, this AI model is service is a multidisciplinary area. We can say it is the combining AI and cloud computing. Similarly, if you can see here, there is another type of technology that is called as quantum computing as a service, which consider two area again. One is quantum computing, another is computing, any type of computing. So I can say cloud computing or any type of computation that is required for quantum computing technology. So it is represented as a yellow color triangle. So that yellow color triangle indicates that the technology will sustain for more than 10 years. So you can see it is showing it is greater than 10 years. So like that, you can find a number of technologies that are available in this Gartner hype cycle, and what is the life period of each and every technology. Means when this technology is going to be an absolute. That's why the time is, you can see the time axis is now further divided into 4 parts. One is the innovation trigger, where the technology is completely new. Like nowadays, people are searching for quantum computing. Quantum computing is considered as one of the emerging area, right? Because there is not much work is done in the field of quantum computing. Or people are also focusing on how to write a quantum program, or how to run a program in a quantum based computing, right? So these are the some of the aspects related to the quantum computing, which is not that much mature in comparison to other technology, right? Similarly, you can see after innovation trigger, we have peak phase. So over a period of time, if a technology is providing you a lot of advantages with less cost and better flexibility and scalability, definitely the technology will come into the peak period. Like you can see in peak period, you can find cloud and generative AI is one of the popular technology. API centric software as a service, SaaS management platforms. These are in the peak phase. Every technology again after peak phase, it will come down, right? It will not be a peak phase throughout the years, right? So it will definitely ups and downs is there for each and every technology. So after peak period, it will go come for disillusionment period, then the slope of enlightenment, and finally the technology becomes obsolete. Like you can see the earlier handsets which we used in our childhood, that is no more mature, no more people are using, right? It means the technology is completely mature, but still some innovations are going on with respect to smartphones or iPhones and lot of phones, right? Because people have interest in that particular product, right? If a product is not, people are not interested, then there is nobody is going to look into that particular product. Like you can see some of the technology which is absolute or they are fully mature, that is called as cloud migration, private cloud computing, or cloud management services. These all are in the matured phase, right? So they have already reached that plateau. But other technologies that are not reached that particular plateau. So whenever we choose a particular technology, we need to primarily focus on this Gartner hype cycle. Although this hype cycle is updated twice in a year, so we have to always focus on the latest hype cycle, and we have to know that what are the technologies that are trending. So definitely, if we do any research work in the trending area, then obviously people are going to accept our solution. Like you know that as a researcher, if I write a paper where the technology is absolute, then nobody is going to accept that work, right? Until unless there is a extraordinary work is there, right? So you can see that most of the areas what you can find here, that is merging from one area with another area. So similarly, we are targeting the artificial intelligence and cloud computing in this faculty development program. Now coming to the global cloud marketplace, as I said, marketplace means there is two type of people who are available in the marketplace. One is called as the customers, okay, or you can say buyers, customers or buyers. Another side we have the providers, or we can say sellers. Okay, like every day also our day-to-day activity, we are going to market to purchase vegetables, or we purchase the groceries, right? So we are considered as a buyer, and those people who are providing these we consider as a seller, right? So that is called as a marketplace. But the term that is new here, that is called as cloud marketplace, because this is not a physical marketplace that way which we experience in our day-to-day life. Or I can say if you go for an e-commerce site like Flipkart, Amazon, or whatever site you like, so that is a cloud marketplace. So there is no physical market, right? That is everything is completely virtual. So you search for a particular product, and based upon uh, your likeness or whatever your requirement, if it is fulfilled, then you are going to purchase that particular product. So in the left side, you can see we have customers, and right side we have provider. So customer has some specific requirement. I have some requirement in my mind. You have some requirement in your mind, right? So which you need to fulfill, right? Whether you go for your own infrastructure and fulfill, or you can depend upon the cloud infrastructure to fulfill it, right? For example, you want to start a startup company. So for your startup company, you want a website, right? So you can host a server, right, with the internet connections, and you can, if you know how to prepare a website or how to develop a website, you can develop your own. But if you are unaware of it, so what you can do, you can request a third party, okay, which who is going to do it for you, and you have to pay for it, right? So similarly, that comes the marketplace, right? If we do if we do it virtually, then we sometimes call it a cloud marketplace because everything is stored in the cloud. So now in this cloud marketplace, as buyers and sellers are there, so we should know what are their requirements. So what is the requirement of buyer and what is the requirement of the seller? So for example, if you go for this particular user, okay, I'm talking about this particular user. This user is asking, I need to grow my infrastructure, but I don't know for how long. Like I told you, if you start a business, so there is no guarantee that you are going to succeed in that business path, right? So you are you have a doubt that you may say that I am in full of risk, okay, or high risk is there that it is not going to be adopted in the market. That's why you are not sure that how long you are going to continue in the market. So in that case, if you purchase infrastructure, let's say you purchased two different servers. So if your company is not going to run for a longer period of time, then what is the use of that particular server? So there is no need, right? So that user is saying, I want to grow my infrastructure, but I'm not sure about future. So I don't know how long I am going to use that particular infrastructure. So the solution will be provided by the cloud marketplace. Similarly, if you talk about the second user, I can say this is user one, this is user two. So the user two is saying, I cannot invest in the infrastructure. I just started my business. So whenever we start a new business or startup, we have scarcity of the budget. Okay, we don't have sufficient money, right? So we cannot purchase the infrastructure. Is somebody will ask you to purchase a server of 10 lakhs, you are not going to purchase it, right? So the solution can be provided by cloud marketplace, right? Similarly, coming to user three, the user three requirement is that I want to focus on the application logic and not maintenance and scalability issues. So as a developer, if you go for the application developers, the main responsibility of the developer is application logic. They have to write some code, right? Which we call as application logic. But early days, what happened? Developers are also responsible for maintenance of the hardware, right? Also, they are also responsible for scalability. So, for example, you want to develop a particular software, and later a point of time, you want to scale it to a bigger number. Right? Today, you are using, let's say, two servers. Later, you have decided that I want to grow from two servers to, let's say, five servers. Okay. So, developer has to do that one. So developer is responsible for everything, starting from application logic, maintenance and scalability, security, monitoring, everything is done by the developer, right? But nowadays, because of cloud computing, the developer is only responsible for application logic. They are no more responsible for maintenance and scalability. So who will be take care of this maintenance and scalability? The maintenance scalability will be given by the cloud service provider in the cloud marketplace. Okay, so user 3 requirement is also going to be satisfied. Now we'll go for user 4. User 4 says that I want to access and edit my document and photos from everywhere. Like suppose you have a computer system in your office, you have another computer system at your home. Okay, So you can download desktop Google Drive, right? So whatever work you are doing in your office, if internet is connected to your desktop office as well as your institute, your office computer, as well as internet is connected to your home computer, then the same piece of file you can find in your home, right? So that any point of time you can edit, or any point of time you can access any particular document. So that is also the requirement of a particular user, right? Even if I am going to, let's say, US, for example, I'm moving from one country to another country, I don't want to take my computer system. Okay. So if everything is stored in the Google Drive, you can still access the computer system in any country. Only the requirement is the internet, right? So the user for requirement can also be satisfied in the global cloud marketplace. So these four users, whatever you have seen, they are the buyers, okay, or they are considered as the customers. So they have some specific requirement, and they are asking this requirement to the cloud marketplace, right? So they are in doubt that whether these things can be fulfilled by the cloud marketplace or not. Because in order to fulfill any requirement in the cloud marketplace, we should have that particular service. If we don't have service, we cannot provide it, right? So now if you come to the provider end, so the right part is our provider end. So what this provider says, so let me write provider one. So provider one says that I have a lot of infrastructure that I want to rent. Okay. Provider one says that is having lot of infrastructure that I want to rent. So suppose somebody is having surplus infrastructure. Like we know that in village area, if you talk about vegetables, or you talk about groceries or rice or dal, so there is a surplus amount, right? So they want to sell the surplus amount, right? Once they fulfill their local need, they want to uh, send the remaining things to outside to sell that particular thing. So they will come to the cloud marketplace and they can fulfill the requirement of user one. Okay, user one is require some kind of infrastructure, and provider one says that I have a lot of infrastructure. See, both the requirements are satisfied. If both of them are agree, then they can access the resources in the cloud marketplace. Similarly, if you talk about the second one, that is provider two. Provider two is saying that I have surplus infrastructure that I want to make use of. Okay. So somebody is having surplus infrastructure, then only that require that surplus amount that can be given to some other person, right? So the provider two also can participate in the cloud marketplace and serve the users, right? Similarly, if you come to provider three says that I have infrastructure and middleware, and I can host applications. So if a user, if you want to host any application, or you want to write application logic without thinking about the maintenance and scalability, so provider 3 can fulfill your requirement, because provider 3 is saying everything I will manage. Okay, I can host applications, maintenance, security, everything you take care of, will take care by that particular provider. Only thing is that you have to only concentrate on the application logic. So that can be fulfilled by provider 3. Similarly, you can see the provider 4, which says that I have infrastructure, right, and provide application services. So they want to provide the services. Okay, anybody require that particular services, they can provide it, right? So both buyer and seller are meeting in a particular point, which we call as cloud marketplace. So they can exchange the resources in the cloud marketplace. But before they initiate any kind of services, so there is a agreement they need to sign. Like when we purchase a particular refrigerator, or you can say air conditioner, or any particular product, we are bound to a particular certain terms and condition, right? So provider is giving some terms and condition. So if after using a particular product, if you feel that the product is not working, then you can claim. So up to how long you can claim this one, there is a limit that written in the terms and condition. So there is certain type of agreement. So in the cloud marketplace, we have certain type of agreement that is called as service level agreement. Okay, or we call that is a SLA. So SLA is a agreement between the buyer or seller, or you can say customer and provider. So they agree to certain terms and conditions, because later point of time, if the things are not working, then buyer can claim or seller can also claim. If some harmful things happen, okay, the resources are damaged or something, some virus came or something like that. So provider is also going to claim. So when they claim it, we are going to review that service level agreement. So based upon the terms and condition, we can see and we can find whether a buyer is the buyer is creating problem, or our seller is going to create this particular problem. Who is not following the terms and condition, that we can easily identify from cloud marketplace. So this concept is not new. Okay, this cloud marketplace is there from, you can say, in 2008, and from the birth of the cloud computing. So there are many companies, they are benefited from cloud marketplace. So let us see some of the companies, those who are benefited from global cloud marketplace. So the first company is called as New York Times. So all of us are reading newspaper, right? In early days or nowadays also we are reading e-newspaper, right? So there is a newspaper at Newark. The newspaper name is called as New York Times. So earlier, the newspapers are coming in printed version, but nowadays, apart from the printed version, every newspaper is coming in the e-paper version also. So New York Times decided that why don't we convert this traditional newspaper, which is printed form, right, to a soft copy, okay, or we convert the traditional format to a e format, right, electronic format, so that any point of time any user wants to view a newspaper, or I want to know in 1950, let's say one particular date, let's say New York edition, what are the newses, what is the newses published in on that particular time. So I just want to know that one, right? So I can able to do, if a well-defined portal is there, then I can easily go to that portal, and or you can pay some amount if if it is required. Then you can view that particular newspaper, or you can download that particular newspaper. So New York Times plan to convert all the traditional newspaper into electronic format in a particular portal. So for that, they don't have any infrastructure to move to the cloud. Okay, if you want to start, if you are a non-cloud based company, you don't have an idea, or you don't have any person who will help you to move from traditional infrastructure to the cloud infrastructure. So for this, what they did, they took two different type of services. One is called as Amazon EC2. EC2 stands for Elastic Compute Cloud. Elastic Compute Cloud. So it is basically providing the computation. S3 is called a simple storage service, which is a storage cloud. This is a compute cloud, and this is a storage cloud. Okay. So Amazon AWS provides these two popular services. One is for computation, one is for storage. So they requested Amazon. In fact, they subscribe to two different type of services. One is Amazon EC2 for computation, Amazon S3 for storage, and they are able to convert all the newspaper into the newspaper in a web-friendly format within 36 hours. So this is one of the success story behind the cloud computing. Similarly, Animoto is another popular company, right? Like whenever we are taking photos, later point of time, we want to make a video using those photos, right? We play a very nice music in the background, and we want that these photos is come as a video. Generally, in the some ceremony like marriage ceremony or trade ceremony or some other ceremony, what we do, we capture picture and make a video. Okay. In fact, we hired a particular person. That person is responsible to take a photo and make a good video. The same thing is done by Animoto. You can visit the website of Animoto if you want. If you can submit some photos, and if you want a very good video, then they will prepare everything and give you. So Animoto initially don't have any infrastructure. Okay. So what they did, they requested Amazon Web Service, which is which is under Amazon only, right? And initially they subscribe to 70 servers to initial phases to start their business and to provide the preliminary service. And after that, they have seen there is a huge demand of Animoto. Many people are very interested in their products and services. So what they did, they increased the number of servers from 70 to 8,500. Okay, so you can see there is a huge gap between 70 to 8,500. So I cannot purchase, if I am 70 servers, in order to expand my infrastructure, I cannot purchase the 8,500 numbers of servers. That is practically not feasible. In order to set up a company, if I tell you to purchase 8,500 servers, nobody is going to purchase, right? But in cloud, you can do it, right? But later point of time, if you feel that no, I don't need this 8,500 servers, I am done with the 100 servers, then you can also reduce it. So this shows a clear example of scalability. We can increase and we can decrease based upon our requirement. So Animoto did this by increasing from 70 to 8,000 per hour, and based upon the demand, they are increasing the number of servers or they are decreasing the number of servers. Similarly, there is another company which is, can say, a startup company, that is called as Little Floppy Toys. So this company, actually it is a bicycle rental service based company. So early days, what happened when there is the transportation is not in good condition. Okay, so people usually come from village area to city area, and they go to a bicycle store, okay, or bicycle service store, and they surrender some ID card and they give some security deposit, and they are getting a cycle. Okay, and they are going in that particular city, various places to complete their work. And once their work is completed, they again come back to that bicycle rental shop and they surrender the cycle and collect the security deposit after deducting the service amount and the ID cards and other things, right? The same thing you can do in the Little Floppy Toys, right? So it used Google App Engine, and it is just like a startup company. So they are in the market within 1 week. So they developed an application just like Ola and Uber, that what we are using in day-to-day life. So they are in the market within 1 week, right? And they can expand their business, right, in cloud. But if you maintain your physical infrastructure, maintaining the things is not that much easy, right? Now, coming to with this background, I'll tell you about a very simple architecture that is called as market-oriented cloud architecture. So, in market-oriented cloud architecture, here I'm showing you 4 different layers. So, any architecture, whether it is a network architecture or it is a IoT network-based architecture or cloud architecture, any architecture, if you see, the bottom layers are more or less they are hardware layers. They are more towards hardware, less towards software. But if you go for the upper layers, so upper layers case you will find more towards the software and less towards the hardware. So in this architecture, you can see there are 4 layers as I mentioned. One is the user and or broker. So one first layer is user or broker. So user interact with the cloud from the upper layer. Second one is called as SLA, resource allocator. So I told you SLA is service level agreement, which is a contract between I can say cloud service provider and the customer. Third one is the virtual machine, and fourth one is called as physical machine. So these are the different layers, and this is a market-oriented architecture. It is not a standardized architecture that can be used anywhere. Okay, if you go for any other architecture also, you can find more or less the same component, but not the exact components, right? All the components you may not find. Okay, so in the upper layer, you have user and broker. So user needs a web browser, like you are attending this Google Meet. Google Meet is also a cloud service which is provided by Google, right? So you have a particular link, you are typing that particular link, and with your credential, username and password, you are able to able to log in into your account, and you can enter to a particular meeting, right? So user also similarly, user wants services from the cloud. So what user will do? User will go to a particular cloud service provider. For example, if you go for Amazon, right? If I am interested for Amazon cloud, what I'll do? I'll go for AWS, right? AWS is providing all types of services. So you can type in Google Amazon Web Services, okay, through a web browser. That web browser will give you enough number of search queries, and you can see most of the search queries. Okay, whatever we are searching, that we are getting in the very first few links, right? So similarly, here also you will get some link. So the site that I can visit, that aws.amazon.com, right? So once I visit this particular site through a web browser, my web browser, I can say, let's say all of us are using, I think, Google Chrome or Firefox, or you are using Internet Explorer, right? So something like this, right? So through a web browser, you can type a particular web link, right? Like aws.amazon.com. And if you go to aws.amazon.com, you have to create one account. Okay, you can give your credential, Google credential, or you can enter to AWS through your Google account, right? You create your own account, or by providing your information, or you can go to Google account, right? So once you create an account, they will ask you to write your credit card or debit card information, right? Without credit card and debit card information, they are not going to allow you to use the services, right? So what you will do, you have to provide your credit card and debit card information. So once you provide this debit card and credit card information, a nominal amount is going to be deducted. Okay, like when we register for PhonePe, Paytm, any UPI application, in order to validate your account, they are going to charge a minimum amount, 1 rupee or 2 rupee, and that is refundable also, right? And once you set up everything, then you will get 12 months of free services. 12 months of free services in AWS. But free does not mean that you can go for any amount of resources, right? There is some limitations with respect to the computation or database storage or container, or you can say application development, serverless architecture, machine learning application. So there is some limitations, right? So within that particular, you can say, limit, you can use the resources, right? For example, as I mentioned about two services, that is EC2, another is called as S3. Okay, one is EC2, another is S3. So you are going to use, you are going to get 750 hours, 750 hours per month of free services. Okay, if you go to EC2, then you will get 750 hours per month of free services. Okay, but EC2, that is Elastic Compute Cloud, has several instances. Instances means, I can say, machines, or you can say virtual machines. So there are different type of machines are there. Like I can say micro machines, or you can say uh, tiny machines, or you can say small machine, large machine, X large machine. So different type of machines are there. So based upon your requirement, you can select one of the machine. For example, most of the time we are using the micro instances. Okay, micro instances. So with respect to instances size, again you can see number of computation requirement or computational devices are also different. For example, if you go for X large, you will get more CPU. Okay, if you go for tiny instance, you will get very less. Similarly, when you go to S3, you are going to get 5 GB of storage. Right? EC2 will provide you 750 hours per month. Okay, and S3 is going to provide you 5 GB. Okay, that is free up to 12 months. So after 12 months, they are going to charge you. Okay, so up to 12 months, it is free if you are using these micro instances. Okay, but if you are using higher instances, you may be charged, right? As they have credit card and debit card information, so they can charge you. So every time you need to be careful when you use any cloud services. Okay, similarly, we are getting 5 GB of storage. Okay, 5 GB of storage, just like in our pen drive, we can store something, right? Or Google Drive, we can save something. Similarly, S3 also we can save 5 GB of data. But don't exceed the 5 GB of data. They are going to charge per GB or per let's say MB, whatever pricing schemes are there, they are going to charge that for you, right? So you should be very careful when you use the cloud service. You are not going to exceed the or whatever the overall free space it is given to you. So if you see, like in Amazon, here also you can see there are different type of users are there. Okay, so suppose this user are interested for EC2, right? Elastic Compute Cloud. So that user is going to be interested in computation, but this particular user is interested in storage. So the user can use S3, right? Similarly, some other type of services that you are going to see in the other sessions also, like for database related, somebody can use DynamoDB. There is a service provided by Amazon. Okay. Similarly, there is another database service that is called as RDS. Okay, RDS, which we call as Amazon RDS, Relational Database Service, right? For example, MySQL or PostgreSQL, MariaDB, SQL servers. For that, the user may use a particular service. Similarly, somebody can use another service that is called a SageMaker. So SageMaker is another popular service. Generally, machine learning or data scientist people are using SageMaker, right? So different type of services may be requested by different users. For example, if a user is not aware of the cloud system, it is not necessary that all the users are aware of the cloud system. So they may not aware of the cloud system. So if they are not aware of the cloud system, so they have to take help of a third party to use the cloud service. For example, I can say, suppose you want to travel to some place, right? Some visiting, some tourist place you want to visit, but you don't know how to make a particular plan. So what you can do, you can request to some third party, just like Make My Trip or EJ My Trip. Also, so many other type of websites are there. So they will plan for you. So we are calling them as a broker. So broker has knowledge about that particular place. Also, broker has knowledge about the user. So they are taking a requirement from you, and they are also aware of the facilities given in that particular place, or how to reach that place, what are the facilities available. So everything they are having that information. So what they are doing, they are planning for on behalf of you. So either a user can interact with the cloud services, or on behalf of a user, a broker can use the cloud services, right? Now, when a request is reached to a cloud service provider, like through a Amazon website, you have created an account, you have provided your payment information, and now you are free to use the service, right? So you are making a request. For example, you want to create a T2 dot micro instances. Okay, if you want a T2 dot micro instances. You want to create T2 dot micro instances. So you will make a request. So whether your request is honored or not, or whether your request is accepted or rejected, that will be depend upon your cloud service provider, right? Suppose, for example, maximum capacity of a particular system is, let's say, 10 GB. Okay, 10 GB of, I'm saying, let's say, RAM. Okay, but if I am making a request of, let's say, 20 GB of RAM, so is it possible to provide 20 GB of RAM if the requirement maximum available resource is 10 GB of RAM? No, right? So there is a unit called as Service Request Examiner and Admission Control Unit. So Service Request Examiner will first check your requirement and see that whether that requirement can be satisfied by a cloud service provider or not. So if it is not satisfied by a cloud service provider, it is going to be rejected. So most of the cloud, they are able to provide a very large amount of resources, but if you go beyond a particular limit, then nobody can provide it, right? Service request examiner is taking care of that. And there is admission control unit. For example, I can say only 5 virtual machines can be created on top of a physical machine. Let's say, for example, by looking into the capability of a particular physical machine, I can say on top of a particular physical machine, you can create only, let's say, 5 virtual machine. You cannot exceed 5 virtual machine, right? But your requirement is more than 5. Okay, initially you agreed with 5 number of virtual machine. Later you are requesting for another virtual machines. So it is not possible to provide it because there is a limitation, right? Your maximum requirement can be fulfilled, that is 5. But if you are exceeding 1, then that will be moved to maybe other physical machine to provide the resources, right? So service request examiner and control unit is taking care of that, right? It is taking the request of the user or broker, and based upon that it is going to check whether the request can be fulfilled or not, and admission control unit also checking that sufficient resources are available to host it or not. Otherwise you are going to go for migration or you have to reject. So that is going to be taken care of this. So there are different type of approaches that can be followed in this particular unit. For example, there is a customer driven service management, okay, or computational risk management, or autonomic resource management, because it is not possible to make all the resources on to fulfill the request of the user. So sometimes we only make 2-3 resources on. Okay, and whenever a request is coming, then we enable other resources. Right. There are some resources are in standby, but there are some resources in the switch off mode also. So if there is a excessive need of the resources, then what we are doing, we are going to provide that resources. Okay, like we are going to switch on some other machines. Some machines are standby and some machines are switch off mode. So we have to find a appropriate algorithm to know that how many machines are in the standby mode, okay, how many machines are in active mode. So that we need to see as a particular algorithm development, right? So these are the some of the factors that is looked into this particular unit. Apart from that, you can see there are some other blocks are there. Like we have, there is a unit called as pricing unit. Okay, so pricing can be considered in different way. Like I can say pricing, maybe I can divide into a price as a peak price, another price is a off peak price. Okay, so peak price means I can say, let's say 12 p.m. to 12 a.m. So the current time is also coming under 12 p.m. to 12 a.m. 12 a.m. means night 12. Okay, 12 p.m. means 12 noon. So within this particular time, we consider that is a peak time. So if you want to take a resource in this time, then that is called as peak time resource, right? Or you will be charged based upon the peak time. And there is another resource that is called as off peak time. So it starts from 12 a.m. and it is continue up to 12 p.m. Okay, it will start from midnight 12 and it will continue up to 12 noon. So why we divide into peak price and off peak price? Because always the peak price is more, off peak price is less. Similarly, somebody can categorize the pricing scheme as fixed scheme, another is called a changing scheme. Okay. For example, I'll say irrespective of your use, okay, there is the fixed price per unit. Like LEDs, if you see the landlines, okay, let's say per minute it is 2 rupees, right? So if you use 100 units, so it is 200 rupees, right? And changing price, for example, I can say if you make first 100 units of call, then it is 2 rupees. But when you exceed 100 units of call, then you have to pay 3 rupees per unit, okay, or per minute up to 200 units. Again, after 200 units, I'll put, let's say, 5 rupees, something like that. That also can be decided. Similarly, pricing schemes also you can focus based upon the supply and demand. Okay. So, for example, supply is less and demand is more, then the price is going to increase, right? Supply is more, demand is less, then price is going to be decreased, right? So mostly if you come to the AI in cloud computing, we use the predictions and forecasting in this particular part to know what is the pricing, what is the pricing of agriculture crop or pricing of the cloud services. So these we focus in how to fix a appropriate pricing scheme. And one of the example I can tell you, like if you go for IRCTC, So all of us are booking ticket from IRCTC. Okay. So IRCTC has started a different plan that is called as premium Tatkal plan, right? That premium Tatkal is based upon the supply and demand, right? If it is a festival season, right? In festival season, you can find the price is very high. But if it is a normal day, then the price is less. So based upon that also, we can make a categorization. Okay, so there are different types of pricing schemes are there. So pricing scheme is also part of your SLA resource allocator, which acts interface between the cloud service provider and the external user or the broker. Similarly, you can see there is another unit that is called as VM monitor unit. So we can create a virtual machine. Like if you install VMware software in your computer system, right? Through VMware, you can create a particular virtual machine. For example, let's say you are using a computer system with Windows as the base operating system. Okay, Windows is the base operating system. The base operating system is Windows. So on top of Windows, you are installing various softwares. So one of the software you have installed is VMware. Okay, VMware is treated as a hypervisor, right? It is treated as a hypervisor, or it is called as a virtual machine monitor, right? Or manager. So what we can do here, on after installing VMware, suppose I want to install Linux. So I can use Linux on top of the VMware, right? So what happens? Your computer system, when you switch on, it will load Windows. But when you start your VMware, then you can go for Linux, right? So there is no need to go for dual operating system. Like early days, we are using Windows and Linux separately. Some space we have allocated to Windows and some space we have allocated to the Linux. But nowadays it is not required. We can go for Windows. On top of that, we can go for the Linux system. Okay. So VM monitor units will check that whether to suspend a particular virtual machine or to resume a particular machine, or a virtual machine is in sleep mode, okay, or it is in awake mode, right? There are different status of the virtual machine, or active mode, okay, or idle mode. So there are different type of modes. If you go to the literature, you can find number of status you can find for VM monitor. So most probably these VM monitor units checks that whether a virtual machine is idle or it is active or it is not in active mode, right? So that whenever a new request is coming, so virtual machine monitor is going to take care of that. So there is a dispatcher unit. In operating system also, we studied the concept of dispatcher. The main role of dispatcher is to move from one component to another component, right? So like that, we have long-term scheduler or long-term dispatcher, short-term dispatcher, medium-term dispatcher, right? Similarly, here also we are using a dispatcher unit. So the dispatcher unit is help us to move from one component to another component. Suppose user is making a request. So the request we need to check by the help of the service request examiner unit. So there we need dispatcher. The service request examiner has successfully accepted that particular request, and the request is going to be executed in a particular virtual machine. So a dispatcher is required. So VM is hosted in a physical machine. So if any communication happens to the underlying technology, then definitely we need a dispatcher, right? Similarly, another unit is there that is called a service request monitor unit. So for monitoring the virtual machine or infrastructure, we are using virtual machine. But another side, we have request, service request, which is submitted by whom? Service request is submitted by the user, right? So whether a user request is processing, or the user request is on hold, or user request is completed. So for that, we have a service request examiner or monitor unit. Service request monitor unit, which will check the status of each and every service request. Similarly, there is a accounting unit. That accounting unit is going to prepare the final how much the charge it is going to be paid by a user. Normally, if you go for Amazon, Amazon is charging the resources per month basis. Okay, it is asking per month basis. For example, I'll say if you use a particular CPU, okay, it is $1 per CPU per hour. Okay, $1 per CPU per hour. So suppose you used for 5 hours. So accounting unit will say as you have used one CPU for 5 hours, you have to pay $5. So there is a dashboard, billing dashboard is there. That billing dashboard is taken care by this accounting unit. Now, if you come to the third layer, we have set of virtual machines. You know, virtual machine is created by taking the resources of a physical machine. For example, I can say this is a physical machine, okay, based upon the capability of this particular physical machine and based upon the requirement of a different user. So what I did here, I have created two different virtual machine here. Okay. Similarly, if you see based on the capability of this computer system or this server, I have created three different virtual machines. So how many virtual machines you can create, that is depend upon the capability, right? Or the you can see whether what the system supports, right? Based upon that, you cannot go for a number of virtual machines, right? So we in the bottom layer we have the physical machines. So when we have a group of physical machines, so here we have a group of physical machine. We call the group of physical machines as a data center. So a data center consists of a set of servers or a set of physical machines. So that's why I told you hardware part is always there in the bottom part, but you can see user, how user interact with the system. User interact with the system by the help of a browser. But how where the service is provided? Service is provided from the hardware level. So if a request is made by a particular cloud, particular user, then that request is going to reach to finally physical machine. Okay, because physical machine will create the from the physical machine only you are going to create the virtual machine by the help of an hypervisor, right? Like VMware, or you can go for KVM, or you can go for XCM. These are the different hypervisor we have, right? So this represents the simple, I can say, market-oriented cloud architecture. Okay, so these all are the what we discussed. Like user broker, I told you they are acting on behalf of brokers are generally acting on behalf of service request. So you can make a request from anywhere. Make sure that you have internet connections. So if you have internet connection, you can deploy your service anywhere in the world, and cloud is going to process your request. And we have also discussed about SLA resource allocator. So in that, I told you about service level agreement. I told you about accounting unit. I told you about VM monitor unit, service request monitor unit, dispatcher unit. We have discussed about the pricing unit and accounting unit. Okay, then we have virtual machine, then we have physical machine. Now, I will tell you more about the pricing schemes because ultimately the cost matters for any particular company, right? If you are using cloud as an individual, you also looking for a cost. If a company wants to adopt cloud, then they also need to focus on the pricing mechanisms, right? So there are different pricing mechanisms you will find in the literature. So I am telling you some of the pricing mechanism which is there in the recent literature. So one of the pricing scheme is called as fixed max. So fixed max says that irrespective of the peak hour or peak hour, so you have to charge $3 per CPU per hour. Okay, we will not look into whether it is a peak hour or a peak hour. Okay, suppose a user is using, let's say 2 hours, then that user is going to pay $6, right? For using one CPU for 2 hours. Like as I said, if you go for Amazon EC2, in Amazon EC2 we are going to get 750 hours of service, free services, right? So 750 hours per month. Okay. So can anybody tell how many hours are there in per month? Can you estimate how many hours are there in a particular month? So how many hours are there in per month? How many hours? Can anybody calculate? How many hours are there in a particular month? So per day it is 24 hours, right? And we have, let's say 30 days. Okay, in average we have 30 days, right? So we consider a month as 30 days and a year as 365 days. We are not going for, let's say odd months or like 31 days or 28 days, 29 days, right? So if you calculate it, you are going to get 720 hours. So somebody can say that if I use a particular instance, okay, let it be a T2 micro instance throughout the day or throughout the month, then also I'm not going to exceed 750 hours, right? So you are getting 720 hours. Yes, Anusa madam mentioned 720 hours, right? So if you use 24 into 7 into 30, right? Means 24 into 7 in a particular week or 24 into 30 in a particular month, then you are reaching 720 hours. But the free resources is given 750 hours. You will never exceed the limit. But this is for only one CPU. But if a person is using two CPU, for example, I am using CPU 1, I am using also CPU 2, right? CPU 1 I am using, let's say, in a particular day, I am using 22 hours. Okay. In a particular day, I am saying, let's say in day 1, I am using 22 hours and CPU 2, I am using, let's say, 18 hours. So although a particular day is having 24 hours, but you are using two CPU for 40 hours. Okay, in average it is 20 hours. So 40 hours is going to be deducted from 750 hours. Okay. If you switch on another instance, it will also take active for some hours. So it is going to be deducted from the 750 hours. Like that, they are going to calculate, and once you exceed the 750 hours, they are going to charge you. Right? So fixed max and fixed min, these are the very simple scheme. Irrespective of the peak hour, irrespective of the price, you will simply fixed price or changing price. We need not worry. It's a fixed price. Okay. And the price is not going to change. Like I told you, fixed scheme and changing scheme. So it is completely fixed. So if it is a maximum, then it is $3 per CPU per hour. Minimum means $1 CPU per hour. So I can say with the maximum utilization. Okay, I can say if you are using a resource at max, okay, then it is $3 per CPU per hour. If it is minimum, then $1 per CPU per hour. Similarly, we have another pricing schemes that is called as fixed time max and min. So in which we consider the peak hour and off peak hour. Like here you can see this is considered as off peak hour. I told you night 12 to 12 noon is considered as off peak hour, and 12 p.m. to 12 a.m. is considered as peak hour, right? So peak hour the charge is $3 per CPU per hour and $1 per CPU hour for off peak price, right? Similarly, if you go for minimum one, okay, where you are not using the resources in a maximum mode, okay, or you are using in a minimum mode. So in that case, you will charge $2 per CPU per hour in the case of peak hour, but off peak hour you will get $1 per CPU per hour. Okay. So this scheme is based upon the peak hour and off peak hour. Okay. There is another interesting pricing scheme that is called as Libra plus dollar. So these three pricing schemes together we call that is a Libra plus dollar. Okay. So Libra plus dollar is comes in three different mode. Libra plus dollar max, mean, and auto. So here there is two dynamic factor we are using. One is called as alpha, another is called as beta. And this alpha and beta value you can monitor. You can change the value also based upon your business, right? You can decide that what is the alpha value, what is the beta value. Yeah, is there any question, Jagdish sir?
Yes, sir. There is one question.
Yeah,
Like,
please.
how do we decide whether we are working on max mode or minimum mode?
No, no, maximum means that is based upon, for example, if you look into utilization perspective, right? So we know what is the average utilization, right? If your average utilization is exceeding, let's say 50%, I'm putting a threshold as 50%. Then I can say, yes, it is in max mode. But if your utilization comes below 50%, then I can consider that is a min mode. It purely depends on the cloud service provider, what threshold we are going to put and how to estimate this max and min part. Is it okay, sir?
Okay, sir. Thank you.
Yeah. So if you go for Libra plus dollar, okay, I told you two factor we are using. One is alpha, another is beta. For example, in this case, I consider alpha is equal to 1 and beta is equal to 3. So alpha is more or less, although it is a dynamic parameter, but alpha we keep a constant value. Okay, 1 or 1, generally we take 1, but beta is a dynamic vector. Okay, Dynamic factor. Sometimes we take 3, and some day we take 4, some day we take 5, so to get more revenue, right? So let us discuss about this, and based upon that, I'll tell you a problem so that it is more clear. So when you go for Libra plus dollar, it uses a fine-grained pricing function. So there is a difference between a fine-grained and coarse-grained. So let us discuss that. Then I'll come back to this particular slide. So actually, granularity is of two type. Okay, I'll tell you later. Granularity is two type. One is called as fine granularity, another is called as coarse granularity. Okay. So why we are going for this granularity? Granularity is nothing but up to what extent a system or a material, or you can say a big entity or big component, is going to be decomposed. Like I can decompose a particular component into two parts. Again, this two part I can be decomposed into another two part, and so on, right? So up to what extent we are going to do? So when you go for fine grain, we define a system with smaller components. But when you go for coarse grain, we are showing the larger subcomponents. Okay. So here Libra plus dollar uses more fine grain, means smaller components. So that satisfies 4 essential requirements. So what are the requirements? One requirement is flexible, another is fair, another is dynamic, another is adaptive. Flexible means you can see, for example, like I told you, scalability is a flexible concept. You can go for 80 to 2500. You can come 2500 to 80 also, right? Or any value, right? But if you go fair, fair means you can say that it is not only providing the resources to a particular user or a particular resource, okay, but it is equally distributing among all the resources, or the request of all the customers are equally treated. So it's one another requirement. Another is dynamic. So based upon the price I am going to gain, okay, I am going to frequently change the parameters. Okay, or it is adaptive. Like if I take a practical example, I can say if you consider bank loan, okay, or any loan. So every 3 months or every 6 months, the interest rate is changed, and we agree to that particular condition, right? So that is a dynamic scheme, right? So different type of requirements we have. So now let us take, if we consider the price as Pij. So here I represent the price as Pij. So we have two index. One is I, another is J. So I is considered for the request, J is considered for node. Like as a user, I am making a request to a computer system. So user request is considered as I, and the node that is going to fulfill the requirement of the user can be considered as J. So the price Pij per unit of the resource utilized by a resource reservation request I to by a compute node J is calculated like this. So Pij is calculated based on alpha into P base J plus beta into P util J. For example, let us take a real life example. If you consider the electricity bill, okay, suppose in a particular month you are out of station, okay, and none of the electronics gadgets or any switch is on. So you will not get the bill is 0, right? You will definitely get a bill, let's say 100 rupees is the minimum charge. Okay, so in that case, the beta factor or utilization factor is no role. Even if beta factor is there, utilization is 0. So it is going to be 0, right? If you are not using the resources. But alpha is a static quantity, right? Some value is fixed, and base charge is also mentioned, right? Like I say, if you are not using electricity, you have to pay 100 rupees per month. If you are not using your mobile phone, you have to pay 200 rupees per month. So it is based upon this particular factor. Or if you take, let's say, railway reservation. In railway reservation case, if you are not booking a Tatkal ticket or premium Tatkal ticket, you are paying only the base charge. Okay, based upon the reservation, you are making a base charge. But when you go for Tatkal, this dynamic part is coming. Or if you go for premium Tatkal, dynamic part is coming, and it is varying with respect to the time, right or not? So every price component has two parts. One is the fixed price, another is the variable price. So how to estimate this price? As I said, P-based price is a static pricing component. So nothing to worry. It is 100 rupees or 200 rupees, that is fixed. Everybody has to pay. Okay. So But second price is based upon the utilization. So we need to calculate the utilization to decide that what is the cost here, right? So let us see how to calculate P utilization. So P utilization is the utilization price is a dynamic price component, which is computed as a factor of P base J. P base J is your base price. So based upon the base price only, we are calculating the dynamic price. But that dynamic price is based upon how many resources you have and how many remaining resources we have. Let us take a simple example. Suppose you have 10 computing nodes or 10 compute nodes. You are a provider, you have 10 compute nodes. And out of 10 nodes, let's say only 2 nodes are free. 2 nodes are free. So if you put in this formula, I can say resource maximum is 10, resource free, remaining resource that is free means 8 is used by some user. So 10 divided by 2 multiplied by P base J means you will get, let's say P base J base price is 100. So how much you will get? You will get 10 in by 2 is 5. So it is 500, right? But let's say out of 10 compute node, all the 10 compute node is free. Means none of the service request is executed by your resources. So in that case, if you calculate, it is 10 divided by 10. Okay, 10 is the maximum resources, 10 is the remaining resources, multiplied by 100. How much you will get? 100. So what you conclude here? The conclusion here is that if remaining resource is less, here remaining less is less or not, so price is high. And when the remaining resources are more, the price is less. Similarly, we can go for any formula. Not necessarily you are going to use this formula to calculate P utilization. I am showing you an example how to calculate P utilization P utilization or utilization price, so that you can incorporate with the base price and calculate the total price, right? So once you determine this, if you put in this, then you will calculate what is the price the user has to pay for a request I, which is going to be executed in the node J. Okay. Now coming to this slide, you can see the Libra plus dollar max case, we are taking alpha is equal to 1 and beta is equal to 3. But when you go for minimum, it is alpha is equal to 1 and beta is equal to 1. And when the user selected auto mode, automatically it is going to be decided. It is same as the minimum mode. We take alpha is equal to 1 and beta is equal to 1. So obviously, if sometimes minimum mode case we are getting less computational resources, maximum mode we are getting more resources. Okay, more computationally extensive resources that we can get. Okay, so based upon that, I'll tell you a simple problem so that you can understand. So let us assume that the base price for utilizing a particular resource at node J is $10. Okay, that is the base price. And the maximum unit and remaining unit of the resource at the same node J for the deadline duration of a request is 150. So maximum units is equal to 100, and minimum units is equal to 50, right? Maximum units is 100 and minimum units is 50. Okay, so the base price here is given as, because of the base price only we are going to calculate the dynamic component part, right? Because it is a factor of base price. So base price is $10. Okay, base price is $10. Okay, now what we are going to do, it is asking us 3 questions. The first question is that determine the utilization price of a resource at the same node J. Okay, we are considering a particular node J for the required deadline of request type. Okay, we have to calculate the utilization price. How to calculate utilization price? I told you P utilization you can calculate based upon how many maximum resources are there. Okay, what is the total number of resources and how many resources are free? So here you can see we have 100 resources, but out of 100 resources, the resources free is 50, because it is remaining free unit of resources is given as 50, and rest 50 resources are occupied by some other user request. So if you calculate this one, you are going to get the value as 2. Okay, and it should be multiplied by our P base price. So our base price is $10. So 2 into 10, I am going to get $20. So utilization price I am getting $20. Okay, now the second question asked, determine the price of Libra dollar max. So Libra dollar max case, we consider alpha is equal to, by default, the alpha value is given as, if you go for dollar max, here you can see alpha is equal to 1 and beta is equal to 3. So if anything is not given, then you can take alpha is equal to 1, beta is equal to 3. Okay, so what I can do? So the formula is alpha into P base plus beta into P util, right? So alpha value is 1, base price you know that is 10, beta is 3, and utilization price you got is 20. So if you calculate this one, okay, you are going to get 10 plus it is 60. So you will get 70. Okay, but when you go for Libra plus dollar minimum, alpha is equal to 1 and beta is also equal to 1. So in that case, if you put in this particular formula, it is 1 into 10 plus 1 into 20. So you will get the value as 30, right? Similarly, if I give a different value of alpha, you will get different value. And Libra plus dollar is following the same mode as Libra plus dollar minimum. So you will get Libra dollar minimum case, the value is 31. Okay, so in this way you can calculate. But when you go for fixed max and fixed min scheme, fixed max says that you have to pay $3 per CPU per hour. Fixed min case, you will get $1 per CPU per hour. Okay, so if the base price is 10, you will directly multiply. So here you will get 30. Here if I multiply 10, I will get the value as 10. Okay, so in this way you can calculate, right? Calculate what is the price the user has to pay to the cloud service provider based upon the resource requirement. Okay, but you may be given with different alpha and beta value. Based upon that, you can calculate. We have already calculated 70, 30, 30, and 20 we have calculated. Here we calculated 30 and 10. Okay, this is another problem. So I left it as a exercise. Only thing is that in comparison to the previous problem, here the alpha value and beta value is given differently. So alpha and beta value is normally by default it is given as 1 and 3, but here the alpha value and beta value is explicitly mentioned. Okay, in that case you can choose these two particular value to calculate it, right? So as I already discussed, I am skipping this part. Okay, now I told you granularity. Okay, I told you granularity means up to what extent you are going to decompose a particular component. So when you go for the coarse grain, okay, we consider a large subcomponents. But when you go for fine grain, we are going for smaller components. So what is the meaning of this larger component and smaller component? That we will see by the help of one example. For example, all of us are filling the postal address while we are filling different type of forms, right? Or when you register in a portal, it is asking you to write the address, right? So there we are filling the particular form. For example, for address, you have only one field. Okay, so there is in that particular form, you have only one field, that is address, and there is a text box, right? In that text box, I am writing, let's say, Department of CSE, NIT Warangal, Warangal pin code, state name, and our country name, right? So all these things are is a larger subcomponent. Okay, although these also having a different type of subcomponent, but it is a larger subcomponent, right? But processing these larger subcomponents is sometimes challenging. For example, I will ask you how many applicants having pin code 506004. So it is difficult to analyze. How many people belongs to the state of Telangana? So it is difficult to identify if we consider a larger subcomponent. So, but larger subcomponents takes less space. And obviously, if I I am storing everything in a single text box, it takes less storage, right? That's why when you go for fine granularity, so this is about coarse granularity. When you go for fine granularity, we are going for smaller components. So instead of this address, I can say you have to write, let's say, street name. Then you have to write, let's say, house number. Okay, or I can say city name. Then I can say district name. Okay, or I can say uh, district name, then state name, then country name. Then I am asking a pin code. So you can see here what we are doing. We are keeping the smaller subcomponents, right? So we need more storage for fine granularity. But fine granularity will help you when you go for searching. Suppose I'll ask you how many people are belongs to the same district, and easily you can write a query and extract the data. So that is the advantages you are going to get when you go for fine granularity. So based upon the typical application, you can decide whether coarse granularity is helpful to you and fine granularity will help you. Similarly, there is also you can see architectures are also developed when you go for a high-level architectural approach. You can find people have also developed architecture based upon different type of characteristics. Like we have seen in the previous lecture about different characteristics, like on-demand self-service, board network access, measured service, right? Elasticity. So many services we have seen. But there is a difference when you go for elasticity and scalability. So generally, elasticity refers to the ability of a cloud to automatically expand or compress. So when you reach a particular limit, it is going to be expanded. Like one of the example I'll tell you, like when you create a Google account, the Google is providing you a 15 GB, right? And very initial stages, it is likely that most of the people forget the password and they create another account. So it is not possible every time to give 15 GB space to each and every user. So what I'll do, I'll put a threshold of let's say 1 GB. With a 1 GB initially, I am going to give you, and once you reach to let's say one third, two third of it, or let's say three fourth of it, then it is going to expand to another 1 GB, right? So if this expansion is done automatically or compression is also done automatically, we call that concept as elasticity. So when there is a sudden up down, then we can be able to manage it because it automatically takes care of this thing. But when you go for scalability focusing on the static part, right? Suppose you need a 2 GB now and tomorrow onwards you need 4 GB. Okay, so the requirement is not that much frequently changing. Okay, so there is no need of elasticity, we can deal with the scalability. And when you come to scalability also can be done in different way. We can go for vertical scalability, horizontal scalability, diagonal scalability. Like in our computer system, if I have a 2 GB of RAM, so early days what happen when the computer is slow, we add another 2 GB to make it 4 GB, right? We add another 2 GB so that this entire system capability is going to be enhanced. So it is 4 GB. Another way what I can do, instead of adding another 2 GB, I'll bring another computer system with 2 GB and I'll connect these two systems. So you have to decide whether you have to go for horizontal expansion or you have to go for vertical expansion. Similarly, sometimes we require a particular you can say either RAM or hard disk to expand it, right? We don't want everything to be expanded. So sometimes our requirements are not completely vertical and not completely horizontal. So in that case, we go for a hybrid type of scalability, which we call as diagonal scalability. So it is required when you go for a particular architecture, whether your architecture supports vertical scalability or horizontal scalability, that you need to determine. Okay, this is one of the high-level architectural approach which I found from one of the good source, that is NPTEL. So they have divided the architecture based upon different attributes. Like based upon the quality attribute, they consider different type of architecture. Based upon the business goal, there is a different type of architecture. Based upon what kind of architectural techniques we are using, there is a different type of architecture. For example, if you focus on business goal, So always you need to focus on what is the market share, what is the stakeholder satisfaction, whether our company is following the regulatory framework or not. We have to also look into total cost of ownership, which we call as TCO, right? That we need to focus. But when you come to for quality attribute, so I need availability should be more. Like if you go for AWS is providing you 99.99 durability. 99.99. Total nines is 11 nines of durability. Okay. So that may be one of the architecture you can follow. Right. Sometimes some people say that availability is not that important, but let's say computation, I need a faster computation. Even if the service is available for 2 hours, if it is do faster computation, that's fine. Somebody can say that no, I need availability as well as faster computation. Somebody can say security is also important. So based upon that also we can build a particular architecture. And some of the well-known architecture you can find here, like stateless design. So many cases we are going for stateless architecture nowadays, right? State means we are keeping some partial information. But when you go for stateless, we are not going to keep any partial information, right? Many people are going for loosely coupled architecture. In loosely coupled architecture, if a particular component is failed, it is not going to impact other components, right? So based upon that, different type of architecture is there. You like security perspective, we can say that claim-based architecture, attribute-based encryptions. So different architectures we have based upon the requirement. Only we can say which architecture is more appropriate in that particular application. Now coming to TCO, if you come to total cost of ownership, as we are talking about the cost, we need to know how to calculate the total cost of ownership. So TCO is depend upon many factors like initial cost, operation cost, maintenance cost, downtime cost, production cost, and remaining value. So we more or less add all the cost except the remaining value, right? So for example, I'll tell a small example with respect to the service so that you can understand how the TCO actually works. So let us start with three variables, not necessarily all parameters you will consider for all type of problem. So here I am showing you a problem with only three parameters, where TCO is calculated as initial cost plus maintenance cost minus the remaining value. So suppose you have two service A and service B. So sometimes your requirement is fulfilled by multiple people. Your requirement is fulfilled by multiple people. So what we will do? We'll see who is giving a cheaper cost, who is providing better service with cheaper cost. That we are going to select. So we have a service A and service B in the cloud. Let's say the initial cost is I, maintenance cost over 5 years is represented as M, and remaining value after 5 years is R. Okay, we consider the variable IMR for representing this. And service A initial cost is $10,000, and let's say maintenance cost is the service B case initial cost is your $20,000. That is the twice the upfront cost of service A. So by looking into the initial cost, somebody will say that service A is better, right? So let us see other parameters also, right? Like if you go to the maintenance cost of service A is $5,000 and service B is $2,000, and remaining value is $2,000 for service A and $10,000 for service B. So if you calculate the total cost of ownership, so you are getting 13,000 for service A and 12,000 for service B. Okay, so initially when you look into the initial cost, there we have an impression that service A is going to be the better in comparison to service B. But overall, whenever we see, we found that service B is less than the service A. Okay, because you need to consider multiple factors, right? Then only you have to select one. So here, obviously, service B is less than the service A. So we are selecting service B as our intended service. Similarly, TCO can be calculated with other factors also. So I am not going details of this one. In this case, the downtime is also considered, right? In the previous case, we consider only initial cost and maintenance and remaining value. But in another case, in this particular case, we consider another parameter, that is our downtime. So you can calculate the cost of the ownership and determine which service is better. Okay, many people also divided the architecture in based upon two factors. One is called as technical architecture, another is called as deployment architecture, right? So in which location you are going to put, that is called as deployment, like public cloud, private cloud, community cloud, hybrid cloud. It is based upon the location. That's why you call it these are deployment models. But when you go for technical architecture, whether you focus on the middleware part or you focus on the cloud stack, where we have infrastructure as a service, platform as a service, software as a service, that also we need to focus. Based upon that, we can make a judgment, right? So they can divide it into these two type of architecture. So coming to XaaS, XaaS is called as anything or everything as a service, because primarily it is infrastructure, platform, and software. But later point of time, people have come up with other type of services like sensor as a service. Some people call healthcare as a service. Okay. Some people focused on security as a security as a service. So overall, we consider it as XaaS. So here we are comparing the different type of services like IaaS, PaaS, SaaS with the network structure, right? In network, what do we have? We have infrastructure. Infrastructure means you have storage, you have physical machines or servers, you have interconnection network. These can be mapped to infrastructure. When you go for platform as a service, we consider the middleware where we are going to deploy the application. We need to focus on the application logic. Our application should run in a particular environment. Like you can say our computer system is running in a Windows environment or it is running in a Linux environment. So that can be considered as a platform as a service. Similarly, we have also software as a service where we focus on the different type of applications. Like Gmail is considered an application, Facebook, Twitter, whatever we are using, they are considered in applications. So we can map the protocol stack, that is IaaS plus SaaS, that is our cloud stack, with the different type of structures like storage, service, and applications. And you can say in the managerial level. So if you go to the management perspective, the upper layers are more or less the management perspective, right? Security will be there in every layer, right? That's why there is a vertical bars, right? Management is a bar and the security is a bar. So infrastructure management is important. User side, we can see the upper layer is having more importance in the management level, right? But our lower layer hardware management is required. That will be done by the provider part, right? So we can compare that. Similarly, here you can see another different architecture where we are looking into who is working in which layer. Like if you talk about IT architect or IT operator, they are working in the IaaS level. But when you go for software architect, okay, or developer, they are working in the PaaS layer, or user, application developer, end user, or the top level management of a particular company, they are working in the top layer, that is the user layer. Similarly, here I am showing you two different architecture which are very famous. Like Microsoft is having a service, that is Microsoft Azure is also providing services like AWS, Amazon Web Service. So here we are comparing the Microsoft Windows Azure platform with Amazon Cloud platform. So the type of services that they are providing is different. So here maybe we are saying Elastic Compute Cloud, that is EC2. So there we make say a different term. Or here we are saying S3, that is simple storage service. But Microsoft Windows Azure platform case, there is different. Database case, we can consider RDS, simple DB, but they are considering different database. Right. Overall, the concept is same, but the way they are calling the different type of services is different. Again, they are also divided into different layer like infrastructure, platform, and software as a service. So another important part in the high level architecture is to go for elasticity. As I said, elasticity is a dynamic term where we can go for scale up or you can go for scale out. So generally we do a vertical scale up. So when there is a smaller scenario, it is better to go for a scale up. Like you have 2 GB and you want 4 GB. So it is better, the size is very small, right? So you can increase it, right? But when there is a large scenario, suppose you have 2 GB, you want 2 GB, right? There is a huge gap, right? So in that case, you have to go for spell out a solution. That's why instead of relying on a single system, better you gather a group of system where they can provide the services. So it is always suggested that if you go for a one cross 64 way of server, which is much more expensive than 64 cross one way server. So if a server is having 64, okay, 1 cross 64, if the component is failed, then the whole network is going to be collapsed. But if you have a 64 computer systems which is performing one task, then it is easy to uh, provide the services, right? So that's why it says that 1 cross 64 way server is much more expensive than 64 cross one way server. Yes, the last part that I want to discuss, that is called as migration. So migration is usually done when the resource is not sufficient, right? For example, here you can see uh, here we have hardware. On top of hardware, we have a virtual machine monitor. So this hardware is a physical hardware, which you can say you can consider CPU, you can consider RAM, you can consider all the accessories related to the computer system. But by taking the same hardware, I want to create two different virtual machines, right? So every virtual machine is having a operating system. It may be a Linux, it may be a Mac operating system, it may be a Windows operating system, and every virtual machine is created to execute some work, which we treat as an applications. So these two virtual machines, which we have created here, they are taking the resources of this particular hardware. Okay, but later point of time, VM1 wants to expand. VM1 wants to expand. Suppose you are using 2 GB, but at later point of time you need 4 GB, which is not supported by this particular hardware. So what we can do? This virtual machine we have to migrate to another physical machines. So this is a physical machine. This is another physical machine. So we can migrate it. So when we start the process of migration, one virtual machine we have to suspend. Right, like VM1, I am suspending that particular virtual machine. I am putting in a storage, and I am finding an appropriate physical machine, and I am resuming my work. Like here you can say I resume my work in another physical machine. So, but suspending a particular virtual machine, storing that particular virtual machine, resuming is called as our cold migration. Okay, or we call it a regular migration, because the computation is hampered. Computation will be not done once you suspend a particular resource. Until unless you resume it, it is not going to. The computation is going to be hampered from the suspend to the resumption part, right? But when you go for hot migration or you go for live migration, so we can migrate while the computation is going on. One of the examples, simplest example I have reported here. For example, I am watching a particular movie in my mobile phone and I have a smart TV. And my mobile phone is connected to smart TV. So I can directly project that in my smart TV. So I can see in my mobile phone, I can see in my smart TV. So here what happened? There is no delay. Okay, even if there is a delay, that delay is considered as a very minor delay, right? So we have to decide which migration techniques we need. Again, there is a lot of challenges when you go for hot migration. When you go for a cold migration, it is quite simpler in comparison to hot migration, right? On the go, if you do migration, it is really challenging, right? So this is also one of the aspects when we go for the cloud computing architecture. Yes, what I can say here in as a conclusion, that we started with the introduction of different aspects. Like I told you about the Gartner hype cycle. I told you about the computing paradigm starting from 1822 to 2016. Then we have seen some of the success stories behind cloud computing, especially New York Times, Animoto, Little Floppy Toys. Then we have seen the market-oriented architecture, and we have seen there is a four-layer architecture. And specifically, I told you about the pricing schemes that are adopted in market-oriented cloud architecture. We have seen two problems related to pricing mechanism, where we use Libra plus dollar and fixed max, fixed mean, and fixed time max, fixed time mean, different type of pricing schemes. Then I told you about the concept of granularity, scalability, and different type of scalability. And I told you high-level architectural approach in three different perspectives. One is business goal perspective, quality attribute perspective, architectural practice perspective. And we have seen also how to calculate the total cost of ownership under this high-level architectural framework. and we have compared with our IAS SaaS PaaS model. Also, we have seen based upon the customer view and provider view, which architect, like IT architect will work for IAS, software architect will work for platform as a service, and administrator will work for a software as a service, that we have discussed. I have showed you the architecture of Amazon EC2 and Microsoft Azure, or you can say Microsoft Azure against the Amazon Web Services. And we have ended up with the migration process. We have seen two types of migration. One is hot migration, another is cold migration. And if you are interested, you can follow the book by Professor Rajkumar Bhuya. It's a very nice book. If you are new to the cloud computing, you can go through this book. This book is very helpful for the beginner to the intermediate level. And if you are interested, you can go for these videos by Professor Somyakanti Ghosh, who offered the cloud computing course in NPTEL. So I have taken some of the slides from this video lecture, so you can refer that. It's all about the this cloud computing architecture. So if you have any question, you can ask.